Hey everybody, Mr. Bennett, welcome back to another video. We are moving into chemical bonding. In order to do bonding, we have to talk about these things called ions. And ions are when atoms have a positive or a negative charge to them. Remember, all atoms, all elements that we've looked at so far have been electrically neutral. We have the same number of protons as we have electrons, positives and negatives canceling each other out to a net charge of 0. Now we're moving into positive or negative net charges, and we do not change our protons. This is very important. Electrons are the particles that tend to fly around and do different things. And so ions, these are caused by atoms. So here I am, a happy little atom, and I either gain or I lose electrons to become ions. So we are gaining or losing electrons in order to become an ion. And remember, our positive ions, I'm going to use blue. These are called cation, C-A-T-I-O-N, pronounced cation. And that is a positive ion. It is a positive charge. Remember, the T looks like a plus. It's a good little memory trick. And that's not why they named it that, but it works. Negative ions, these are called anions, A-N-I-O-N, and I like the acronym A, negative ion. It's negative, and this is gaining electrons, and that means that the cation has lost electrons. So my electrons have gone away, leaving me with extra protons. Negative is the opposite. So I have protons, I gain a few extra electrons. And we can predict our ions, just like anything else in chemistry, which is pretty great, from the periodic table. So I can look at my periodic table, and the main group elements at least, and I can predict what my ions are going to be. And when we're doing our ions, we use something called the Octet Rule. Atoms always want a complete valence, that outside shell. So when I'm losing my electrons, I either lose them all or I gain them all to fill that valence shell, whatever that valence shell happens to be. Hydrogen and helium are the standouts. Remember, they only have 2 valence electrons because they're in shell number 1. Everything else is looking to empty that valence shell and leave me with 8 valence with one of my core shells, or gain electrons to fill up that valence one. So groups and families, remember, this is the number of valence electrons. So if I'm in group 1, I have 1 valence electron. And this particular ion, let me erase this, we're going to color code this guy. I have 1 valence electron. If I have 1, it's easier to lose that 1, donate it, and come back to an empty or a full core shell. So we're going to call this guy a positive 1 ion, a plus 1. He loses his electron, meaning he's positive, so we're going to stick with blue. Shell number 2, I have 2 valence electrons. 2 is much closer to emptying than 8 is, or than it is to gaining for 8. So we're going to call this a plus 2. Skip the middle. Remember to skip the middle. Let me scoot this down so we can see the whole table. Remember to skip the middle. Transition metals, there are ways to figure it out. In my class, it's outside the scope, so we're going to ignore that for now. Group 3, again, I'm still closer to emptying that shell, so these guys are plus 3. Group 4, this is where we get a little bit, am I closer or am I further? So because it's there is a way to do it, we're not going to worry about it, so we're just going to call this X. We're not going to ionize those guys. Now that I'm closer to the far side, group 5, right, I have 5 valence electrons, which means I have 3 empty spots. So this is going to gain electrons. This is going to be a negative 3. Group 6, I'm sure you can guess, is a negative 2 because I have 6 valence. I need 2 extra to complete my octet. Group 7, I need 1 extra electron to complete my octet. And then finally, group 8. These guys, remember, they have a full valence shell already, so they do not ionize. They are not going to become ions. So this is your pattern. 1 valence electron closer to 0. I'm going to empty my shell. 2 valence, same thing. 3 valence, same thing. 4, we call that the middle. We're going to handle those differently in class. And then negative 3, negative 2, negative 1. So based on an atom's column in the periodic table, I know what ion it will become. Remember, skip the middle. Those pesky transition metals. Do not do those outside the scope of this course. If you want others, there's other videos. You can go take a look at those. When we're finding valence electrons, we stick to main group elements. Ions, and here's the kicker, they can bond. Remember, opposites attract. So if I have a plus 2 ion and a negative 2 ion, those guys are going to say, hey, man, hey, here we go. Let's hang out. We're going to stick together, magnetically attracted to one another. That's going to be a later video, but we're moving towards this. They're bonding. Anions, they get a special suffix. We add an I-D. E, and that tells me it's negative. So if we have oxygen is right here on the periodic table. You don't have to fill that in, but oxygen's right there. Oxygen, when it's negative, becomes oxide. It's an oxide ion. And that's kind of your primer into some of the naming stuff. So the big thing for today, ions. Make sure you know on your periodic table how to find different ions. If you want to label up your periodic table, that would be a great time to do that right now. So go ahead, find your periodic table, mark it up. 1 valence, I lose it. 7 valence, I gain it. We can figure out positives and negatives. There's some critical thinking questions on the bottom, as always, so make sure you take a look at those. They will help you think through these processes. They will help you think through the big ideas. In class, we're going to take a look at this. We're going to form ions. We're going to talk about what makes an ion, what doesn't. If you're not in class, leave me a comment, and I'll hit you later. Thanks.